Hello and welcome to this video on how dark matter shapes the Milky Way galaxy. In this video, we'll explore one of the most mysterious and fascinating topics in modern physics, dark matter. Now, some of you may ask, what is dark matter? Well, dark matter is something that cannot be observed, touched, or felt. Some of you may say, so it's like air? Nope. You may not be able to see and touch air, but you can certainly feel it in some ways, like when you're waving your hand in the wind and when you're squeezing a balloon. However, you cannot interact with dark matter in any ways, at least not currently. It is a hypothetical form of matter that does not interact with light or any other form of electromagnetic radiation. It is invisible to our eyes and telescope. Well then, how do you know it exists? What is the evidence? Before answering those, let me tell you about the Milky Way galaxy first. It is a spiral galaxy that consists of a central bunch, a thin disk, and a spherical halo. The bunch contains all stars and a supermassive black hole at the center. The disk contains young stars, gas, and dust, and is divided into 4 spiral arms that extend outwards from the bunch. The halo contains globular clusters, which are groups of old stars, and dark matter, which is the dominant component of the halo. According to Newton's law of gravity, the stars in the outer region should move slower than the stars in the inner region, resulting in a declining rotation curve, like this. This is the expected gravitational effects of the visible matter, which should decrease with distance from the center. It's fast inside and slow outside. However, in reality, the galaxy has a flat rotation curve, like this, meaning that the stars in the outer region move at the same speed as the stars in the inner region. Well, it just doesn't make sense, right? This is when dark matter comes in and solves the puzzle. Dark matter can explain the flat rotation curve by providing an invisible halo of mass that surrounds the galaxy and balances the centrifugal force of the stars. The dark matter halo extends far beyond the visible disk and has a much larger mass than the visible matter. The dark matter halo creates a gravitational pull that keeps the stars in the outer region moving at the same speed as the stars in the inner region, resulting in a flat rotation curve. Dark matter makes up about 85% of the total matter in the universe, and about 27% of the total energy density. The rest is ordinary matter, the stuff that we are made of and that we can see and touch. Ordinary matter makes up about 15% of the total matter and about 5% of the total energy density. The remaining 68% of the total energy density is dark energy, another mysterious component that is responsible for the accelerated expansion of the universe. Dark matter is still a hypothetical and elusive form of matter that we have not directly detected or identified yet. However, there are many ongoing and planned projects and missions that aim to provide more evidence and clues for dark matter. For example, the Large Synoptic Survey Telescope, which is expected to be operational by 2024, will map the distribution and motion of billions of galaxies and stars, and measure the gravitational lensing effects of dark matter on the light from distant sources. The Gaia satellite, which was launched in 2013, will measure the positions, velocities, and distance of more than 1 billion stars in the Milky Way galaxy. We can reveal the structure and dynamics of the dark matter halo from it. The Alpha Magnetic Spectrometer, which is installed on the International Space Station, will search for the signatures of dark matter's annihilation or decay in the cosmic rays, which are high-energy particles that originated from outer space. These and other projects and missions will not only advance our knowledge of dark matter, but also improve our technology, innovation, and collaboration. Dark matter research can also inspire and educate the next generation of scientists, engineers, and explorers, who will continue to pursue the mysteries and wonders of the Milky Way galaxy and beyond. This concludes this video on how dark matter shapes the Milky Way galaxy. Thank you for listening, and I hope you find this video informative and have gained some valuable insights regarding the topic.